Hello everybody, welcome back to UNIQZ, the next generation education partner. My name is Kevin Deshan. So today also we brought you a brand new mathematics question which will challenge you. So first let's go through the question. Today's question is, the perpendicular height of a right regular hexagonal pyramid is 12 centimeters. The length of one side of the hexagon is 9 centimeters. Find the total surface area of this pyramid with the base. So in this question, you are not supposed to use any formulas related to hexagons. So you can use the basic, as a hint I would give you, you can use the Pythagoras theorem, the area of a rectangle or area of a triangle. But other than that, you are not supposed to use any hexagonal, any formulas related to hexagon. So now you can pause the video and try solving this question. So once you're done, you can continue with the video. Okay, so I hope you figured out the answer to this question. So if not, let's go through the question. So the question is about a right regular hexagonal pyramid. So what is a right regular hexagonal pyramid? If you draw, it can be okay. So this is a hexagonal pyramid. So if all the sides of this rectangle of the hexagon are equal, in that case we call it a right regular hexagonal pyramid. So it has been given the length of one side of the hexagon is 9 centimeters. So we can write it 9 centimeters, and the perpendicular height of the pyramid is 12 centimeters. So the height of the pyramid from this base, this is 3D figure. So height of this from this point to the top is going to be how much? 12 centimeters. Okay, this length of one side of the base of the hexagon, hexagonal base is 9 centimeters and height of the pyramid is 12 centimeters. Then we are supposed to find the surface area. Okay, so to find the surface area of this hexagonal pyramid, you can see this hexagonal pyramid is made up of triangles, right? So there are a lot of triangles. So here we have one triangle, one triangle, likewise we have several triangles. So we are supposed to find the area of one triangle, then we can multiply it by 6 and get the total surface area, right? To find the surface area of this one triangle, we have to know the perpendicular height and the length of the base. So the length of the base, we know it is 9 centimeters given, no problem. But this perpendicular height of the triangular surface is not given. But we know the perpendicular height of the hexagonal pyramid, but not the perpendicular height of the triangular surface. So we need to find the perpendicular height of the triangular surface. So if I erase this part, so this is behind this thing. So we have this is the perpendicular height. So this perpendicular height of the pyramid. So this is the perpendicular height. Then we have the distance from this point to this point to the center. Then we have this perpendicular height of the hexagon. So this is 12 centimeters. This one we need to find. So let's make it A, and this is, let's make it L. Okay, so if we know this L, we can find the surface area of this triangular surface. So now let us reduce this 3D figure to a 2D figure. So let me erase this one. I will have two figures for that. One is the base. Okay. So here we have the hexagonal base. So this hexagonal base is this, and this triangle which represents the perpendicular height of the hexagon, which is 12, and this base, the distance from the center to the side of the hexagon is A, and this perpendicular height of the triangular surface is L. Okay. So now we are supposed to find A, then by using A we can find the L. Okay, so I will erase the 3D figure. Right. So now we are supposed to find the distance from here to here, right? That is this A, right? That is this A, right? The distance from this point to this point. So how to find? So for that we will draw this line and we will make this line, right? So if you consider this triangle, this is going to be perpendicular. What about this angle? So the internal angle of a hexagon, what is it? There will be how many triangles? So if you get a hexagon, there is going to be 1, 2, 3. So there are going to be 1, 2, 3, 4 triangles. So 180 into 4 divided by how many sides are there? 1, 2, 3, 4, 5, 6, 6. So it is going to be 30. 30 into 4, which is 120 degrees. So this one angle of a right hexagonal hexagon is 120 degrees. Then if this full angle is 120 degrees, if this angle is 90 degrees, what is this angle? It is going to be 30 degrees, right? So then by using that, you know this length is A, then this is, it is given, it is 9 centimeters. So you can use cos 30. Cos 30 will be equal to adjacent, which is A, over hypotenuse, which is 9. So you will get A equal to what? A equal to cos 30 means root 3 over 2. So you will get 9 root 3 over 2. So I will write it here. A equal to 9 root 3 over 2. Okay, so now we know this value A. What is it? It is going to be 9 root 3 over 2. So if you know this is 12, this is 9 root 3 over 2, can you find the perpendicular height of the triangular surface of the hexagon? So now we have already found the A, right? Now by using that we can find L, the slant height of the triangular surface of the hexagon. So now let us first find the base area. So we need to find the area of the base, then we need to find the area of the 6 triangular surfaces, right? So how to find the area of the base? So suppose I am not going to use, there's a formula to find the area of a hexagon, right? So I am not going to use that formula. I will be using basic mathematics, the area of a triangle, area of a rectangle formulas to find the area of this hexagon. So let us use that, okay? So now you can see we have 2 triangles and 1 rectangle, right? So we know this length from the A, this is 9 root 3, right? So the distance from here to here is going to be twice, which is 9 root 3. So let me name this A, B, C, D, E and F, okay? So your total base area, area of the base area is going to be area of ABF plus area of CED. So it is going to be, since these two areas are same, it is going to be twice the area of ABF plus the area of this rectangle, which is BFEC. Okay, so area of this one plus this one is going to be 2ABF. The area of the rectangular part is going to be BFEC. So how to find the area of ABF triangle? So ABF triangle area is going to be 2 into half into base. The base is BF. BF is going to be twice A. Twice A means 9 root 3. 9 root 3 into perpendicular height. What is the perpendicular height? For perpendicular height you can use, you know, sine 30. Sine 30 is going to be equal to opposite. Opposite is this perpendicular height. Let's write it B. So B over this side, the hypotenuse is given is 9. So sine 30 is half. So B is going to be 9 divided by 2. So let's use half into base into perpendicular height, which is 9 divided by 2. Plus, this is one thing. This is one thing, and the other one is the area of the rectangle, which is going to be, this is going to be 9 and this is going to be the distance from B to BF. You already saw it is 9 root 3, right? So then your area is going to be 2 to 2 will cancel off. Then it is going to be 9 times 9, 81 root 3 divided by 2. 81 root 3 divided by 2 plus 9 times 9 is 81 root 3. So it is going to be 81 root 3 divided by 2 plus 81 root 3. So this will give, you can take the common denominator. It will be 81, you can take 81 root 3 outside. 81 root 3 if you take outside is going to be half plus 1. Then it is going to be 81 root 3 times 3 over 2. So now you can do the simplification. So when you simplify, you should get the answer 210.44 centimeters square. So now we have found the area of the base, which is 210 centimeters square. Okay, so I will write it down separately. The area of the base is okay. So let me erase this calculation, and I will only write down the area of the base, which is 210.44 centimeters square. Okay, done. Then now I need to find the area of the triangular surface. So what is the area of the triangular surface? Okay, so now we have found the area of the base, right? Now we need to find the area of the slanted surface, right? So now let us find what is that. So first of all, let's find L. What is L? Because you need, to find the area of the triangle, area of one triangular surface is equal to half into base. Base is 9. Then 9 into perpendicular height. The perpendicular height is going to be the slant height of the, that is, which is L, right? So how to find L? L is going to be 12 squared plus 9, this thing, whole thing squared, which is 9 squared into 3 divided by 4, right? Divided by 4. Then it is going to be half into, so no, let me find for 6 surfaces, right? Area of, this is the area for 1, then you need to find area of 6 such surfaces. Area of 6 triangle surfaces is going to be equal to 6 into half into 9 into, then what is this? 12 squared. I'm going to take the common denominator. So common denominator, then 12 is 144. 12 squared is 144 into 4 plus 9 times 9, 81 into 3. So this will give you are going to cancel off 3. 9 times 3 is 27. 27 into square root 144 into 4. 4 times 4, 16. 1 remaining. 4 times 4, 16. 16 plus 1, 17. 1 remaining. 4 times 1, 4. 4 plus 1, 5. 576 plus 81 into 3. 3 times 1, 3. 8 times 3, 24. 243 divided by 4. So when you simplify this, you should get the answer 386.35 square centimeters. So 300 so here this one you will get the answer. I will erase this. So when you simplify this whole thing, you will get the answer 386.35 square centimeters. So 386.35 square centimeters is the sum of all the 6 surfaces. Now you are required to find the surface area of all the surfaces including the base. So now what you have to do? You have to add this base area with the area of the surfaces. So total area will be equal to total area equal to 210.44 plus 386.35, which is equal to 596.79 square centimeters. So that is the answer. So today we solved a kind of a long answer, but a different question. So without having any knowledge about hexagon, so I didn't use any knowledge about any formulas or any nothing. I didn't use anything about hexagons, right? So I just used the Pythagoras theorem, the area of a triangle, area of a square, area of a rectangle. So by using this knowledge only, I solved all these questions. So nothing extra is used other than the area of a rectangle, area of a triangle, and the Pythagoras theorem. So I hope you learned something from this question. So let's meet again in another similar question. Thank you very much for watching.